Hey, oh, it's me, Panacutter, and welcome back to Stream. Hello, everyone. Nobody is here today. I don't know. It seems like Twitch has a stroke today. I don't know why, but I guess Twitch has a stroke today because, like, the stream announcement got out very late, and I was not able to update my stream information in regards of the push notifications. The push notification message, I was not able to change that one. So, very weird, very odd, but here we are, streaming live. Yeah. Streaming live. I got a new background, as you can see. I want to change it a little bit because I think right now it's streaming in fucking 4K. I want to change that, but I'm not quite sure how I can define the aspect ratio. So, or the resolution. Set resolution. It's the way to link someone to a HD. So there is a way to do things, and I can change it via the VQ query parameter, apparently. There we go. I don't know in which quality it's now streaming. I hope not in 4K. I hope it doesn't stream in 4K right now, because that would be shitty. I mean, I got a blur filter going on. Give me a sec. Maybe we can change that to an even lower. Let me try small. Maybe that does something. This but scaled, but like then upscale would be great, but no. Not quite sure about that. But we can increase the noise a little bit. Okay, that's a bit too much, I guess. Isn't it? Let's go something like that. So, okay guys, welcome to the stream today. Today we're gonna play nothing. Today we're gonna work a bit. Hold on a second. Gonna have to do some stuff pretty quickly. Ah, fuck! We're right back. Okay. That seems to have worked. I'm not quite sure right now. So... Okay, let me switch over. Let me switch to the music. There we go. So, okay, guys, as you can see, we got a new background here. At least over here. Maybe I'm gonna add it also over on the programming stream, but too much stuff is happening. And I think it's streaming in 4K right now, which is not great, but anyway. I got a warm cup of tea, I got some Spezi, and let's go. Hot? Holy shit. Tea is very hot. Okay. Okay. My tongue is dead. So, let's switch over to the programming screen. Actually, hold on. Let me try that out. I'm gonna add... this video source here. And I'm gonna place it all the way down here. That didn't work out as planned. Yeah, it's probably streaming 4K. So because I'm using the VLC source right now. Okay, there you go. So guys, first of all, a couple of things, changes since last time. I mapped now pretty much everything over to Gorm now, so tags, releases and whatnot, everything is now made with Gorm, and it's beautiful really. Even like the get tags here, which is a very important function. I don't know if we did that last time, where we get the amount of where we get all the tags of a given plugin. I have, oh no wait, that's the normal get tags to give all available tags. I want to get the get package tags. So, and over here in get package tags, we then get the package tags, and it's so easy to do that. It's beautiful. Yeah, doing the error handling and we're good to go. So that is great. On the other hand, we also have paging. We now have for example, now we have, instead of get packages, we now have list packages, and list packages gets the gets pagination. These are two query parameters, the page query parameter and the count query parameter, so that we can get the stuff paginated. And I also adapted the get packages query now to support this. And for this, we are using scopes, and scopes just simply allow us to insert functional wise more stuff to a given query. So for example, we have here paginate, and this just simply like defines an offset and a limit to our selection query. And we just simply get the data, calculate that a little bit, like calculate the offset, plug it in, and then use it directly in here, and it's more readable now. So you can see, okay, we now make a query that uses pagination, and we do a simple select, which is implied with this find, and we try to find our packages. And with that we have a page needed package retrieval. Isn't that cool? Then I also started to work on the front end. So what we do have in the front end is I got here a SvelteKit project using TypeScript, and I also have added Tailwind CSS, and I also have added Svelte Material UI, which is contains simply some typical widgets or components you use in your web applications that look cool and that behave in a specific way, and that's used all around. And so this material UI stuff is essentially like a defined proposal by Google on how to like some guidelines provided by Google in regards on how to design some UI elements. And so this is this material design essentially containing all of that all of that stuff. Looking, I mean, they are made so that they work really good with each other essentially. And so they provide here also some sources, even like the design stuff, like how does the stuff have to look and so on, what you can and what you should and should not do, blah blah blah, a lot of things. And they also have like the different components, like the different elements, which are good to use. And Google says, wow, goody. They also have some sources, I think, but those sources are usually the map to the different frameworks. So as you can see, I think it was it somewhere here? No, it apparently was not. No, here it is. Like you can, like, they have provided some like libraries for different things, and there are then also libraries that adapt the web library to specific frameworks. And what we are using is Svelte Material UI. And we are using this. So this is essentially a Material UI port, but for Svelte. I'm not sure if it contains everything, but it contains quite a bit, and I'm using that right now in the web page. And let's have a look at the web page. So this here's the home screen. This uses the paginated list of components. It doesn't look good, like at all. I'm still working on it, don't worry. But for now, that's the page. And if you go into like here one package, you can see we go into package test. We also redirect, if you put in package and then the ID of a package, we redirect to package internal name, and then it shows us the display name, description. It's not formatted, but it is a description. Then we also have like a source code here, and then we also have a link to the author test, user test, which I haven't made yet. And then we have here a list of tags, the list of tags this package has. And we have here like the control tag, the display tag, and as you can see, if we hover over those, we have then a description. So this is like some material UI stuff. So like these tags themselves, the widgets for the tags, also called chips. I'm using, and then I'm also using the tooltip here to then display the description of the different tags. What's going to be more interesting is the edit page. So if we go over to the edit page, you can see I'm using here again Material UI inputs. So like an input for the display name, an input for the description, and for the test. You can see we also have some hint texts and whatnot, and placeholder text. So if we're going to remove that, we're going to have, you can see description, and it moves then up, and then we can type some stuff, and then it stays up there, blah blah blah. And then we have here the update package button, which doesn't work right now. I don't have any API to update things into the DB. But I have made this. So I'm using the chips again. Also, the buttons are provided by Material UI. So, yeah, you can remove tags like that by clicking on the X. And I made the whole the behavior of typing it in, removing them, and that you have like this pop-up here, which tells us these are the available tags you have. You can then just click on them and then add them to your tag list, and you can just remove them if you want to. I did something broke, I think. Oh, come on. There you go. Works again. I think it was a tooltip that messed up. Hey, look at that. Tooltips were the latest thing I added, and I thought it will be easy, but apparently it's not. I forgot about something, as it seems. That like, if there is... So it seems like if a tooltip is open, and I remove that guy, the tooltip may stay there and cause us some issues. Very annoying. And now I can't interact with it because the tooltip is in the way. So annoying. Okay, gonna have to figure that out. For now, we could remove the tooltips. But okay, anyway. So, and you can also like if you then use backspace here in your input field, you can remove the tag at the latest point, and you can see it directly adds that stuff then to down here. Okay, so we got again weird issues. So we now got display down here, and if we remove one more, we do not have control. I don't know why we do not have control. I think that's due to the tooltips, because that worked. It worked. Now you can see we don't have anything. Okay, well, anyway, so you have available tags, so these are your available tags, but now look what happens if you type. So if I type now D, you can see it directly fills this in. It has now two lists, so now it has like available tags that match which start with what you have already typed in, and available tags which don't match with what you have typed in, but you're still able to use them. So so this is like essentially an internal search feature then even. And you can see the first entry it was able to find that matches your what you have typed in gets edited here and directly marked. So that means if you continue to type, it overrides that. But you can see now it can't find any available tags, so it doesn't fill it out. But if you type in D and hit enter, then it uses the everything, even the blue stuff. So it then directly goes into display. Okay. So you have a cool way of editing tags. I'm not quite sure why it bugged out now. Probably due to the tooltips. I'm not sure though. But I guess it's due to the tooltips. Because like before that they worked rather flawlessly. So let me try to remove the tooltips for a second there. Let's see if that still is bugged out. No, it's not. Okay, so it indeed were the tooltips. Well, anyway, you can see we now got cool little things. So you have to hello. Stuff that bugs out, apparently. I'm not quite sure why it bugs out, though. So don't ask me, I don't know what is happening right now. Something broke. Failed to execute insert before or node. Why tooltip? What are you doing, tooltip? Nobody cares about you. I mean, we still have tooltips over here. Why does tooltip break everything? Holy shit. Let me comment that stuff out. I mean, if it breaks everything, that's not good. Okay, let's retry. There you go. And then enter. Okay, here we go. Working stuff again. Okay. So. Okay, yeah, so you can edit tags, okay? Good. And you can view them if you're in the non-edit version. And now also so this is the latest thing before the tooltips, which is an admin panel for the tags where you can open up and then like change the display name, change the description. You can see it automatically updates it if it registers a change and you then hop out so that you commit the change, then it registers it directly and displays it. You can add a new tag, and if you add a new tag, it directly focuses and highlights everything in the tag name so that you can directly start typing out your shit. And if you hit, then you can't hit it multiple times. So the new tag, if you just leave it, you can see it doesn't save. It's not allowed. You have to change it and only then it saves it. And then you can also create a new one. You can also remove some, as you can see, if something is open and click that button, it closes due to some internal weirdness. It's the easiest way to do. And even if I have this guy open, I can remove it easily, and you can see I can remove the different tags as I want to. And this is the new tag admin panel with which you can manipulate different tags. Isn't it nice? So, yeah. Now, being able to close things. Delete the different tags. So, yeah, that's the front end I have worked on. The front end can only like retrieve data from the API because the API only contains retrieval stuff. So, there is that. And yeah. Now, also, so now we have two things we can do, guys. Two things we could do. If Turtle would be here, I would want him to decide on what we're gonna do. But he's not here, apparently. Okay, so, or if someone else is here, you feel free to ask, to say what we're gonna do. So, we have two options to do. The first one will be we're gonna work on GraphQL. So, like adding a GraphQL API to our backend. And the second option will be to add some to try to add some authentication to our backend. So these are the things we could do. Problem is just apparently nobody is here. The chat is empty. I'm very sad and disappointed. I guess I'm gonna check out the resources Wilsel sent me in regards on in regards of GraphQL. I'm just opening up some thingamajigs. And there we go. So now we got some thingamajigs with which we can work. So, by the way, we don't need these here. So this is the first thing. GQL Gen is a Go library for building GraphQL servers without any fuss. GQL Gen is based on a schema-first approach. You get to define your API using GraphQL schema definition language. GQL Gen prioritizes type safety. You should never see map string interface here. GQL Gen enables code gen. We generate the boring bits so you can focus on building your app quickly. Still not convinced enough to use GQL Gen? Compare GQL again with other Go GraphQL implementations. Install a new Go module. I already did that essentially. Add to your project's tools.go. Initiate GQL config and generate modules. Start the GQL server. Is there a main file? There is api.go, which then like initializes API, including GQL handlers. If you are on the Linux, you will need to install the following packages, blah blah blah. Create it for initialize it as a Go module. Create a tools.go file and a GQL and as a tool dependency for your module. To automatically add the dependency to your Go mod run Go mod tidy. You want to specify a particular version of GQL Gen, you can use Go get for example, blah blah. Building the server, create the project skeleton. GQL again init. This will create our suggested package layout. You can modify these paths in GQL gen.yaml if you need to. Config file. The entry point to your app. Customize it however is fit. Server.go. Define your schemes. Implement the resolvers. Now I have a working server. To start it, go run server to go. Don't eagerly fetch the user. This example is great, but the real world fetching most objects is expensive. We don't want to load the user on the to-do unless the user actually asks for it. So let's replace the generated to-do model with something slightly more realistic. By default, GraphQL will use any models in the model directory that match on name. This match can be configured at GraphQL. And run GraphQL generate. You've run this into Okay, and for what is this? Creating typeset conversion. All you have to do, create execute go over. So like my problem with it is, so it seems like models. Okay. So you can say GQL and then you have the different resolvers. And there are GQL types. There are generated, and then there are customers. You also have like DB, Postgres, and then there is a mod. Create mod. And it contains here a mod, which is in Postgres types. And over here, okay. But I think that's for other stuff. So we're actually defining the Postgres type over here. And here we also have like our GORM parameters. I mean, it makes sense. And this is a SMR model. And that's just an ID. And SMR dates. With created it, updated it, deleted it. Okay. So, I mean, that's, I think it's fine. So this here is some GORM stuff. The problem is like right now, like this guy here. Okay, and that's the client for Svelte. Okay. So like my problem right now is this data structure here. So he says like package that all contains the generated runtime. A package for all your graph models generated or otherwise. Which contains a graph and then model. I mean, if that, I don't know if that is true. I kind of doubt it. We have a graph folder here. We have a GQL folder and we have a generated folder. I mean, we could check out the YAML. So we got models. And then there is generated and then there is model gen. So there is user and then mods, and then we have like resolver. So these are models. It's like, if I understand this correctly, you have user, fields, mods. And here we have schemas, and then there should be a mod scheme. So this here is the mod GraphQL. The mod scheme essentially. And then there is mod. And then we have like here get mods, new mods, blah blah blah, and query, mutation. And then we have here users, authors for example. That's quite interesting. And mod reference. So the question right now is GQL models. There is user. So and here is mods, and then we got like fields. Authors has a resolver. Version has a resolver. Versions has a resolver, and latest version also has a resolver. And that's like mod. Now that means we have author, version, versions, latest versions. So these are resolved, and the question is, what about these here? That's like my main issue. I don't quite get like models. Models underscore gen, a package for all your graph models, generated or otherwise. Models underscore gen. The question is, how can I define that? So there is like model and file name models gen inside of generated. It's like maybe generated. And there is custom models. But like, isn't it called models underscore gen? And we have like generated.go. It's like, now I get it. It's like if we clone the repository, that stuff gets automatically generated. So it's excluded probably from the repository. My biggest question then is, where does stuff out of the generated get used? Essentially. Like, I have just some front-end changes, okay. So I guess we're gonna try it out. So we just simply go in here and do what they tell us. Can you ignore that? And tools.go. So this is to be added over here. I'm gonna add a new file, tools.go, and we're gonna add that stuff like so. Gmod tidy. And then there is a server.go. Whatever server.go will do. I guess it will do things. Right? Probably will do things. So now there is a server.go file which uses package main, which I absolutely freaking do not want. So instead what I'm gonna do is I'm gonna copy that shit and remove the server.go file. Delete. Because like that's just initialization shit, which we kinda do not need. Which is good. So now I can go into the main file over there. And then do this stuff here. So we have our logger over there. And instead of doing this weird thing here, just leave it. And then we have query, and then we have playground. So that's the GraphQL playground. Then we also do not need this here. And then there is like generated. So so the question is, which generated does it mean? I guess it means this guy. And then there is like new default thingamajig, new default server. I have no clue what new default. Okay, new default server wants to have this shit, which I do not want. So like I have Gorm open here, and here I'm opening up a new echo. Oh, here we say HTTP. Okay. Here HTTP.handle. We do not want that. So what we're gonna do is we say e.handle. Can we do that? Raw. I mean, is there a way to like? Any. Haha. There you go. E.any. Cannot use net HTTP. Okay, wait. Golang echo HTTP handler. How do I hook echo with HTTP? I want to. Golang at http.handler. At scd handler. How to pass objects around middleware. Okay, actually, hold on. Maybe I have an idea. Can I open up the documentation for that guy? I want to have the package go dev. And now http.handler. And then there is rep handler. Type handler func. So maybe handler. Okay, wait, handler func. Okay. So if I say any, maybe I can say. How's it called? Handler func. Okay. Handler func. Echo handler func. And then dot handler func dot wrap. No, hold on. New echo handler func. How am I supposed to use this? Maybe there is an example. Into echo handler func. Okay, maybe. Wait, can I just directly do that in echo? Oh, I can. Well, okay. And then we say handler.handler. Oh wait, hold on. Let me playground.handler. Okay. Okay. So wrap handler. And we've got our playground here. One more thing, and we're gonna remove the new. And this SRV type server echo wrap handler. Does that work? It looks so weird. But this here is now mainly multiple package. What? Where's that supposed to go? I mean, wasn't tools supposed to go there? GQL. Hey. Next, create a to and add GQL as a tool dependency for you. Why do they not even list that freaking file? Okay. Well, let me add a new folder then. Tools, and I'm gonna put you in there. Because like, what the frick? So now with that all out of the way, let's boot that shitty thing up. Hooray! So we are listening. Great. So now if we go localhost 8000/playground, we are in the freaking GraphQL query playground. So that actually worked. I didn't expect it to work, but it did. This stuff here. This is great. I'm not quite sure about the query. I have to admit, I'm not quite sure about the query yet. But for now, let's go with that. I mean, this here apparently takes an HTTP handler. Wait, no, that's the grep function. I mean, I get an SRV. I have no clue what the SRV is. This is a server, and whatever the server does is weird. It has a weird execute a thingy, retrieve the server. I don't know what this is supposed to do. I have absolutely no clue. Okay, let me undo this here, because I'm not quite sure if I understood that fully. It actually just says HTTP handle, and then it expects this here to be a handler. Like, it looks certainly like this is exactly what it wants to be. It's so odd. It's so freaking odd. So if I say query, it actually worked. Okay, I have no clue what the magic behind this here is, but it seems to work. So, okay, fine, I guess. If they are happy, I'm happy. That's at least how I think this should be. Okay. So now everything necessary is in here, and there is like a lot of generated garbage in here. And we got a schema, so we got some to-do schema things. I have no clue. So playground. So there are docs, so we can have a look into query with to-do. So example. So we're gonna try to do this now. So we can say to-dos. Internal server. Okay. So let's see. What are the issues? Not implemented. Okay. I mean, what did you expect? This file will not be generated automatically. If so, it serves as dependency injection for your app. Add any dependencies you require here. So there is now a resolver thingamajig. So the question is, how can we do resolvers? So this is the scheme. Okay. I mean, that's good. So that's the scheme. By the way, hold on. Let's copy that URL pretty quickly. I mean, we have to define our scheme in a sec. Before that, we're gonna have to investigate a little bit further. So let's gonna get rid of this, and we're good to go. Next up is we're gonna have our resolver. But well, we do not need this here. I mean, there are a couple of things we can get rid of. Oh yeah. So we have now generated .go. We have our models. Okay, so here we have our models. We have to-dos, users, stuff like that. Do not add. Yeah, okay. And then we have like generated.go here, which is do not edit, code generated. New executable schema. I have no clue what this stuff is supposed to do, but okay. And then we have our resolver, and here we have schema resolver. This file will be automatically generated based on the schema. Any resolver implementations will copy through when generating any unknown code will be my. So there's create to-dos, mutation and query. And then we have like different resolvers here, and then we have here a panic because we have create to do and to-dos which are missing. And these resolvers go where exactly? Okay, so this is like essentially just this getting through here. Okay, so this will create, yeah. So define your schema. GQL is a schema first library. Before writing code, you describe your API using the GraphQL schema definition language. By default, this goes into a file called schema.graphqls, but you can break it up into as many different files as you want. The schema that was generated for us was bullshit. Implement the resolvers. When executed, GQL generate command compares the schema file, GraphQLs, with the models, graph models, model stuff, and whether it can, it will bind directly to the model. That was done already when init was run. Well, edit the schema later in the tutorial. We will edit the schema later in the tutorial, but for now, let's check out what this look at what was generated already. What the fuck? If we take a look at the schema resolvers to go, we will see the times GraphQL couldn't match them up. First, it was twice. Create to-dos. We just need to implement these two methods to get our server working. First, we need to somewhere to track our state. Let's put it in GraphQL resolver.go. The GraphQL resolver.go file is where we declare our apps dependencies like our databases. It gets initialized once in server.go when we create the graph. So the main question right now is like, okay, you got this stuff here now, but what does it want to tell us? Check our state. State of what? Of us. But what are we? Seriously, what are we? In which context? Declare our apps dependencies, like our database. Files is where we declare our apps dependencies, like our database. It gets initialized once in server.go when you create the graph. Huh. Okay, so that's... Okay, wait, that's interesting. Okay, so we're gonna put this in here. Hold on. How do they do that? So we're gonna put in resolver in here. In the graph resolver. How does SMR API do it? I mean, they then too have to have the same thing. So that means they should have in their... They should have like a resolvers thingy. Is it in here? Yeah, and then there is a resolver.go. And then there's a resolver. And then here we create the different resolvers for mod, mutation, query user, blah 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 blah. But it doesn't relate to the DB, so I guess it uses the DB as public, as global variable. It accesses that maybe. I'm not quite sure. Not a good approach though. But okay, so I understand. So resolver is generally the context structure essentially for everything GraphQL related. So if we want to share some data between GraphQL itself and some other stuff, put it into the resolver to use it as a trampoline. Okay, let's continue with our guide. Actually, let's close this guy and continue to look over here. Okay, returning to GraphQL schema.resolvers.go, let's implement the bodies of those automatically generated resolver functions. For create to-do, we will use math.rand to simply return a to-do with a randomly generated ID and store that in memory in the in-memory to-dos list. In a real app, you're likely to use database or something other backend service, obviously. But okay, so this is create to-do, and then we have like some stuff. We're just gonna copy it because holy shit. I just want to get something up and running, and then we're gonna continue to have a look at that later on, I would say. And then we have to return the to-dos. Just gonna wait, no, that hasn't changed yet. So run the server, and then we have working. Actually, no, we have to change it. So now we just R is the context. So what? Request query resolver. And query resolver extends resolver. Huh, okay. Okay. And then there is a context object, so that's like context pattern of Go, I guess. So we're gonna have to investigate this context object, or what this context object actually wants to tell us. I mean, there has to be a reason why it exists over here. So we will have to have a look, I guess. So for now, I'm fine with that, and we're gonna store that. So now we're gonna restart our backend, and then we run, and then we try to do the things. So on a browser, here is some queries to try. Start with creating a to-do. Okay, we're gonna do. Okay, so we're gonna go in here. So we're gonna refresh for now. Gonna wait. Undefined rand. Import. Method rand. And start. Okay, so it's up and it works. Okay, so we all have access to the playground. So I'm gonna put that down, query it. So we have created a to-do. Okay. And then to-do 1, 2, 3, 4, 5, and there we go. So now we want to list find query find to-dos. Let's go. I have to go over here, put that down, and it lists all the to-dos. Okay. Can we also, so like I have done something weird previously, so let me try to do that again. Oh, okay, so now it doesn't even work. Okay. To do doesn't even work, so you have to use a query. Oh wait, you could do this and then you say to-dos. Then I say to-dos. And then I say give me the ID. If I ran that, we get all the to-dos with all the queries. So is there like a default query then, or how do I have to, like, what is the, I guess, so I have a suspicion right now. Could it be that like this guy here gets called? No. I want to add the different ones. Give me a second. Okay, let's run this again. Oh! I just noticed. So like query here goes to the query resolver. The query resolver is just a resolver, so that's why it does that weird thing. And the query resolver is over here, and then that means if you access the to-dos, this query resolver calls this to-dos function, I guess. And then we are supposed to return the to-dos and the error. How it will continue, we will see. But okay, I think I understand. So now, don't eagerly fetch the user. This example is great, but in general world, in the real world, fetching most objects is expensive. We don't want to load the user on the to-do unless the user actually asked for it. So let's replace the generated to-do model with something slightly more realistic. Create a new file called graph model to-do go. What? Okay. Now I'm okay. Okay, hold on. Where does this go? To-do.go. I'm gonna insert some stuff. Okay. By default, GQL will use any models in the model directory that match on name. This can be configured in GQL gen. And run grun. Okay, so now we have to run a weird thingy-majig again. I'm not happy about running these here. If you run into this error, no go files, while executing the generate command above, follow the instructions in this comment for a possible resolution. Unknown field user instruct literal. Well, that's an interesting issue. If I have to say. And there is user. I don't get this issue. Now if we look into resolvers, we can see resolver. Let's implement and you can see a new resolver. Can we? Yes, we can. There is a user resolver. So we're gonna change that guy. Finishing touches. At the top of our resolver to go between package and import at the following line. At the top of resolver go between package and import. Ah, so it automatically does that. Hooray! This magic comment tells Joe generate what command to run when we want to regenerate our code. To run, go generate recursively over your entire project. Use this command. It's magic. Oh, cool. That's cool. That's lovely. That's just lovely. I mean, there has to be a to-do model, right? Somewhere. Oh, right. This is now this to-do thingy, huh? But I mean, somewhere has to be a user. Oh, I get it. Creates to do changed now. So like previously it did like text, and now it's user ID input user ID. So fix this line. That's what it tells us. Now I get it. Okay. Yep. Makes sense. Okay, so with that we got now a new user here. And what you can do now. Okay, so he adds that over and over again. Okay. Good. So now we also material icons. Wow. Okay, so that means if we run now Joe generate, it should not fail anymore, and instead of finish completely, and then we can try out to do some magical. I hope. I want to see some magico. Can I query for users now? Can I? Can I query for users? No. So there is no, but I can like query for to-dos. And then I can query for the user. Essentially. Can't I? And then there I can query for everything I want, I guess. And I can query. Can I query for ID twice? Huh. Okay, well that makes sense. So wait. If can I say bam and then say like create? No. Okay, hold on. Can I create? No. Okay, so how was I able to create that create mutation? Okay, so I'm not quite sure what this to-dos is supposed to, why that thing works. It's like a normal query then, or what? Okay, well, I can say query and then I can like ask for to-dos and and this right now just confuses me. So like query and then there's find to-dos. Query, and I can apparently say find to-dos. query and then find to-dos. And now I have probably to specify what I want out of the to-dos. And no, and then I say to-dos. Are you fucking kidding me? To-dos. And then ID, and with that I get all the frick. Mutation. Okay, like over here we got like query, and then there is like a fields to-dos, and then like what I want from the to-dos. And then there is also mutation, which is called create to-do, and I get as an input a to-do and as an output a to-do. A new to-do is the input, and a new to-do consists of text and user, and the output to-do exists of ID, text, done, and user. Okay, where does this new to-do defined? Down here. New to-do. Okay. So I guess that ended up in here. Models, new to-do. Huh. And like here we have the normal to-do. Interesting, interesting. So okay. We can now say create to-do. If I got it right. Wait, no. Now I say... Okay, wait. And now I say create to-do. And now I have to provide an input. Which consists of text meep. And a user ID. 3. Is that how you're supposed to do that? No, create to do. Well, you say input double point. And then you say text and user ID. Do I have then to do this here to finish it up? Or what is user ID supposed to be? Oh, it's supposed to be a string. Why does it have to be a string? Okay, don't think that this here will work out. So I probably have to do this here, which is weird. Mutation, create to do, and then create to do. Wait, I have to call it? I don't quite get it why I have to type that 2 times then. Like, why? This makes sense, but why does this should not work? Create to do. And then you have to specify create to do. This is weird. Now, oh, okay, now I can define. Okay, let's run create to do, and we have created a to do with a specific ID. And now we can add some more, and some more, and some more, and now we can say find to-dos, and now we get all the different to-dos we just created. Okay. Interesting. Very, very interesting. So Give me a second, guys. Boop, boop, boop. And done. Okay. Just got a spam on the Discord server. Okay, so we got this now, which is great. So now let's figure out how to do that. So there is like create to do. What I want to understand is how do we know? All right, so we get new to do, and new to do has these definitions. Can we say some data is optional and then based on that retrieve some information? Is that possible? Like, do we have to give user ID or can we give user ID? No. So new to do exclamation mark probably means it's required. And this here and then in a return value, this probably means you're guaranteed to get that information, huh? Is that nah, wait. Yeah, wait, actually that may be the case. Can I check something pretty quickly? I want to have optional data. So if we go into the schema GraphQL, so we have this stuff, you know. If we say this new to the text or the user ID, let's go with the user ID, is not required. Does that mean this thing is now optional? It would be great. It would be great. So I'm gonna generate our stuff now since we have changed our schema. So I'm gonna changing the scheme now. Have changed the scheme now. And what we're gonna do now is we're gonna okay, so yeah, right. So we have changed the scheme now. So okay, user ID has changed. So what we have in here now is this here is a pointer. It's optional. Oh my goodness. Okay, this makes me actually really happy. So we say if input, actually can we say input dot user ID equals input dot user ID or string? Sadly enough, we cannot do that. So I guess we're gonna check the input user ID. If this is not given, or if it is unequal nil, we're gonna say input.user ID unknown. Okay, so that's what I want to try out again. So then I want to change this to string unknown. I'm not quite sure how to do that though. Is it that? Is it, how do you like create a new string? How does that work? I want to, okay, hold on, I have to search. Go lang create string pointer. Initialize string pointer instruct. The one line wouldn't be needed. Apparently... No. You were assignment with something like this here. I mean... Why can't it be easy? Oh gosh. Okay, let's use the utility then. So let me add a new Go file. Let's call it just simply util. And this function contains string, gets a string and returns pointer string. And then it says return s. There you go. Now go be happy. I don't know what the matter is, but here you go. Ta-da! Okay. And then we have to dereference it over there. And now let's go. I want to check it out. So it probably now is optional instead. So here you have like explicit requirement, implicit optional. Because usually it's the opposite way around. But here it seems it's like that, I guess. So let's go playground. So if we go into mutation, and then there's a new to do, you can see there is no exclamation mark anymore. So my get, and this here also it says it's fine. So if we go, if we say now, okay, give me the ID, give me the name, give me the user, there, give me the ID, give me the name. Give me the text. And if we run that now, create to do. We're gonna get stuck over there, which is fine. And we continue, and we have our internal server error. That's not nice. Why do I have an internal server error? What's the reason behind the issue? Invalid memory address or null pointer. What? Fucking kidding me? Oh. Kick me. There we go, and then user unknown. User known, user unknown. The ID is unknown and user unknown. Great! This worked flawlessly. Okay. I actually expected it to work like that. I already suspected. So, yep. Good. This is good. This is genuinely great. Next question. We are requesting stuff. We are requesting a to-do. So how do we... Wait, hold on. There, to-do resolver. I just... No, wait. There is user... We get an array of to-dos. And here we just get a to-do. So the question is like, okay, now here it's obvious. Actually, it's not. I would want to know what has been requested, and I then return the data as it was requested. But like the question is, how can I say you wanted this information? Okay, so right now we have to do, and then we contain user and user, and then we contain ID. Whatever ID is, that would be really good to know what ID is. Is this a string? What is this? Can I convert that to an UN64, please? Whatever. For now, at least, whatever. So we got user. So I haven't. So, and then we say, okay, to do. This is our to do. And then instead we just say, okay, this here is user. And we call it user. So does it directly understand that this here is now supposed to be user based on the JSON? Or how does it know that this field now is this field? Like, how does it know that? That would be interesting to know. So right now I'm guessing it's doing that through the JSON. But who am I to tell? So what happens if I say blah 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 blah? So I expect the generate to fail. Honestly, I expect the generate to fail. Because otherwise I'm not sure how the link will be done. It's not failing. Does it work then? Or is it the order in which things are done? Is it the order? That's not what I wanted. I wanted to regen shit now. Seriously, that's something that has to be solved. So you can handle that totally fine. Still understands that. Is it because... So... And I guess it's this here. Oh, there it is. So this user here is probably the user from over there. Oh, okay. I'm gonna accept that. Let's leave it as it is. So now... I want you to have to specify what you want. Like, I don't want to guarantee you that shit. essentially. I want you to tell me what you want. And then based on that, I'm gonna request. We have this here. But I'm not guaranteeing you that to get everything. So ask me what you want. And I guess that happens based on the context here. And we're done with this getting started, so... What is APQ? A transfer with every request. Field collection. There we go. That's more. I think that's more what I want. Often it's useful to know which fields were queried for in a resolver. Having this information can allow a resolver to only fetch the set of fields required from a data source, rather than overfetching everything and allowing GQL Gen to do the rest. The process is known as field collection. GQL Gen automatically does this in order to know which fields should be part of the response payload. The set of collected fields does, however, depend on the type being resolved. Queries can contain fragments, and resolvers can return interfaces and unions. Therefore, the set of collection fields cannot be fully determined until the type of the resolved object is known. With a resolver, there are several API methods available to query the selected fields. Collect all fields. It's the simplest way to set the query fields. It will return a slice of strings of the field names from the query. This will be a unique set of fields and will return all fragment fields, ignoring fragment type conditions. Calling collect all fields from a resolver will yield a string slice containing a field A, field B, and field C in the above example. Collect fields CTX. Collect fields CTX is useful in cases where more information on matches is required, or the set of collection fields should match fragment type conditions for resolved type. Collect fields CTX takes a satisfies parameter, which should be a slice of strings of types that the resolved type will satisfy. For example, given the following schema, so we have an interface shape with an area of type float, and then there is a type circle that implements shape and contains radius float and area float. And then we have a union with shapes, which equals to circle. The type circle would satisfy circle, shape, and shapes. These values should be passed to collect fields CTX to get a set of collected fields for resolved circle object. Collect fields is just a convenient wraparound collect fields that cause the later with the selection set automatically passed through and resolve. Practical example. Say we're following GraphQL query. Flow blocks ID block, ID title type, choices ID title description select. We don't want to overfetch our database, so we want to know which fields are requested. Here's an example which gets all requested fields as a convenient string slice, which can be easily checked. So we have get preloads, which is... I don't know what that is. Again, returning strings. Get nested preload. What is preloads? And then there are get nested preloads and then get preload strings. This doesn't get mentioned anywhere. We just have flow blocks. Give me flow blocks. So, okay, these are kind of a helper function. So if we call these helpers in our resolver, so the resolver is flow blocks. Okay. Which returns flow blocks, an array of flow blocks, which are actually optional. I don't understand, whatever. And then we fetch preloads. This will result in the following string slice. Block type, block choices. Blah 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 blah. So get preloads. So we got get preloads, get nested preloads, get operation context, collect fields CTX. What? Okay. Get operation context. Returns the operation context, and that returns GraphQL collected field array. And then we have a prefix. Okay, and then we're gonna return a couple of strings, and these strings are then just combined with the prefix. Okay, so that's what the get preload string does. So get nested preloads returns then just simply all the different field names, essentially, in our case. So what we're going to do is we're going to iterate over the fields we have collected with the collect field CTX. Okay. So there we get, and then we like get this combined thing, and there is column.name. So that means column here is essentially the field name, column.name. And then there are preload, and then we say preloads equals append. Okay, so these are the return values, I guess. Huh. Wait. I didn't know that in Go you can do that. So you can directly call this, like name this return value, and then it defaultly initializes it above. You can set this stuff and you don't have to put it into return. I didn't know that works. I didn't know. Now I know, and I'm happy that I know that now. Okay, this may be cool. Okay, good to know. Yes. Okay, prefix column. So essentially we just have our column, and that's like mostly everything we need. Here we just say preloads, get nested preloads, CTX GraphQL, collect fields, column selection, prefix column, collect fields. So you are essentially saying, okay, you're gonna add now the other stuff. So you're gonna add now more, like in here, like the, say, flow blocks ID, and there's a block, and then you have choices, and so like getting the choices happens with this here. So there's a collect fields, and you have like prefix column. Prefix column is like this, so that means you should then have like block.choices.id. Over here you can see that. Okay. Yes. I'm not quite sure how you're gonna convert this to an SQL query, if I'm being honest, but this makes sense. So if we want to get all the fields, you just say GraphQL get operation context CTX, and you get like this CTX, which we need for the collect fields. But I mean, you can directly work with context though. So sometimes it's a bit weird. I'm not quite sure why. Operation context. What operation context is supposed to do. Anyway, collect fields. And because we don't use context anywhere else, we just use it for get nested preloads and collect fields. But collect fields can work with the context directly. So this is a bit weird, honestly, but whatever. Okay, we got that now. Query complexity. query complexity. Provides a powerful way to query your data, but putting great power into the hands of our API clients also exposes you to risk of denial of service attacks. Can you get the GQL gen by limiting the complexity of the queries you allow? Custom complexity calculation. Okay. I'm not... Scalars! Built-in! There are built-in maps, okay. And any. Wow. Schema directives. Restricting access based on user role. Has role double point, admin. Okay, this is interesting. So this is now authorization, guys. Declared in the scheme. Directive is role, exclamation mark, on field definition. Next run go generate, and GQL gen will add the directive to the directive root. So there is now a directive root structure somewhere, I guess in the resolvers thingy, or there is a custom file. Who knows? Well, there is then a function called has role, which gets context and the object interface, resolver and the role, and you have to return. Okay, the arguments are parent context, the object containing the value that was applied. For field definition directive, the object input object that contains the field. For argument directives, a map containing all arguments. Okay. Next, the next directive in the directive chain, or the field resolver. This should be called to get the value of the field, argument, whatever. You can block access to the field by not calling next ctex after checking whether a user has required permission. For example, args, finally, any args defined in the directive schema definition are passed in. Where is args? Oh, here, this role essentially, okay. This is resolver, and object is then contain the input object that contains the field. Implement the directive. So get the user based on a context. Check if it has a role, and if it doesn't, I return an error. And otherwise I say I return the next thingamajig. Okay. I'm stretching. Okay. Okay. So whew. The question is, how do we now adapt that to our network, to our system, okay? So, I mean, we have database, so this here is our data storage. So, like, this does the whole management, and then we have, like, over here in the main, we have the API, the REST API that connects to everything, and then on the other hand, we have other stuff. And then we have, like, our GraphQL in our graph folder over here. So far this seems fine. So let's go and try to write some GraphQL scheme, shall we? So we got like type to do. By the way, hold on. Like we have here GQL, and then there is like models, ID model, and then there are things. This is weird. Okay, hold on, we're gonna have to read through this. Where are all the schema files located? Globals are supported. Globs are supported. Ah, okay. Boop. Where should the generated server code go? Well, graph generated go. Package generated. Uncomment to enable federation. Whatever federation is. Where should any generated models go? Graph model models gen. Package model. Where should the resolver implementations go? Layout, follow schema, directory, graph, package, graph. Optional. Turn on use GGL field name tags in your models. Woo! And that's cool. Optional. Set to speed up generation time by not performing final validation pass. No, we don't need that. GraphQL gen will search for any type names in the scheme in these scope packages. Should we use them? Okay. So these are these schemes. Okay. This section declares type mapping between GraphQL and Go type systems. The first line in each type will be used as defaults for resolver arguments. First line in each type. First line used defaults for resolver arguments, and the others will be allowed when binding to fields. Configure them to your liking. So what is this ID? I just want you in 64, nothing more. Wow. Okay. Scary. Wait, and there should be int 64 somewhere. I mean, there is int and marshal int 64. I want the freaking U in 64, honestly, but I have no clue how to define that. There's a U in 64, I don't know. I'm only allowing U in 64 as IDs. Okay. So now let's go in here and define our stuff. So we got a package, and the package consists of these things: ID, name, display name. Let's go. So we got an ID, then we got a display name, then we got a name, we got a description and a source link. Description, string, source link, which is again a string. Creator ID and creator. Oh, so now we get like just simply creator essentially, which is in this case a user. And last but not least is tags. Tag array. I'm not quite sure how you define that, but I think you do it that way. If I look down here. So now we got a user. So, okay, we got that now. So let's go with a user. A user has an ID, a name, and a bio. So it has a name, a bio, then a Google token, admin, which is Boolean now. Email and verified. Email and verified. Boolean. Ta-da! Next up is tag. ID, name, description, verified. Type tag. ID, name, string, description, string, verified, Boolean. And last but not least, packages. Oh, wait, what? Well, technically, yes. Then I could retrieve all the packages of a tag. Packages. Package. And like then a user technically would have like also packages. Package. And by the way, these probably should be like more like that. So okay, now we got the last one, which is a release. ID, package ID, name. Okay. Releases does a package to also have. So hold on, creator, tags, packages, releases. Release. Type release. By the way, hold on. Let me restart because we now have since we have a plugin for GraphQL now, so why not use it? There we go. Now we got some color in. So this here's ID. It has a name, has a description. Contains is part of a package and has a source link. Sweet. Package. Has a source link. Oh right, wait. It doesn't have to have a source link. It may have a source link. A package may have a source link, but a release has to have one. So then we have a version and a fin version. So version string. Then there is a fin version string. And then we have verified hash, verified boolean, and a hash, which is a string actually. Guys, we will make a short break. I will be right back, and then we're gonna continue on the queries, and I'm gonna try to implement the first query. So, see you in a moment.
Fighting for, well baby you are all that I adore. If love is what you need, a soldier I will be. My heart is yours to keep. You're wired to be breaking, and while your soul's asleep, I'll be waiting, I'll be holding. You keep on running, you're running, you're running. I keep on chasing, I'm chasing, I'm chasing. You keep on lying, you're lying, you're lying. I keep on pushing, I'm pushing, I'm pushing. I keep on coming, coming, coming. You keep on touching, touching, touching. I keep on living, living, living. It feels like robot love. My passion overheats. You shut me down, I'm fading. My system's on repeat. I'll be waiting, I'll be holding. You keep on running, you're running, you're running. I keep on chasing, I'm chasing, I'm chasing. You keep on lying, you're lying, you're lying. I keep on pushing, I'm pushing, I'm pushing. I keep on coming, coming, coming. You keep on touching, touching, touching. I keep on living, living, living. It feels like robot love.
So guys, back again. We're gonna check out. We're gonna tune into someone's stream pretty quickly. Into BrainDG's stream, because apparently BrainDG is using fix a cam. So okay, so here we got BrainDG. Who's currently using the Fixer-Cam mod, which is nice. Look at him go!
See, I've ballsed it up already. I've got to do that first. So then I, G, move, slide, G, and move in game. Okay. This is the combination I've got to do. So I
Just gonna ask him some stuff, because I want to help him out because like BrainDG is like one of the
String of things again.
greatest fixed cam users essentially. Like what he does is crazy,
Slide.
in my opinion at least. In my opinion at least.
I, G. Slide, G, middle on.
So,
I, G.
by the way, give me a second, guys. I'm gonna try out something.
Yeah, I'm gonna put it up to 100. I just forgot to do it at the start. I, G. Slide, G. Move along. I, G. Slide. Move along. Shit. This one?
So how can you do that again?
I, G.
I need to go into
G.
this guy. No, not that guy.
Probably laughing at me now. But Barry, why are you doing it that way? This is a stupid way of doing it.
And there's Google Chrome. Okay, great. You guys don't hear him anymore, but I do. So, okay. That seems to work. So okay, hold on. So So give me a second, guys. Okay, so instead of to-dos, we're gonna go packages, package, and we're gonna ignore this stuff for now. Oh, damn it. Sadly, that's not how it's gonna work out. Okay. Ugh. I'm just giving support BrainDG a bit for Fixit Cam, since like he's essentially one of the main promoters for Fixit Cam, and I'm very happy about that. And now he's figuring a little bit out in regards of field of view and depth of field, because he didn't know that this is now a thing. So we got now packages, and I'm gonna have to try to assemble a query for Okay. So packages. I would say I'm gonna try to generate things now. Cannot find the file specified. 64. Weird.
Oh, cock.
So. Oh god. Oh god. Oh god. Prodigy, what are you doing? So, generated. So I'm gonna go in here. Guess I'm gonna change it to enter. Or actually, can we change it to just uint? Maybe that will work. Oh, come on. I need to find type uint. That seems better. New to do, not declare by package model. Schema resolver. I mean, obviously. So, So okay. So GraphQL field how was it supposed to be again? Like, how do they do that again? By the way, what is this? If you notice, some query can make hundreds of database queries, often the mostly repeated data. Let's take a look why and how to fix it. Add a to-do user resolver looks like this. Where ID. I'm going to use low level SQL here. All of this will be favorite ORM. The query executable called query to-dos resolve, which does select from to-do return and to-dos. Therefore, each of the to-dos concurrently called the to-do resolve a select from to-do resolver. Select from user where ID equals user. Oh. Yeah, that's not good. That's not good. But even worse, most of the to-dos are all by the same users. We can do better than this. Data later. What we need is a way to group up all of those concurrent requests, take out any duplicates and store them in case they are needed later on in request. The data loader is just a request scope batching and caching solution popularized by Facebook. God damn it. We're going to use data loader to build data loader to build our data loaders. In language generics, we could probably just create a data loader, but Golang doesn't have generics. Instead, we generate the code manually for our instance. Okay. Because you need to distinguish presence and using maps. String Goganite, you should end up with a solver that looks like. Okay. I don't get what get operation context does, honestly. We are iterating through all the columns, and then we say preloads, and we say get nested preload. Wait. And then column dot selections. Those are the new fields. Column dot selections. There we go. That's a query. So this is like our packages. Whatever this rep query trace is supposed to do. So we say resolve context, get field context. Okay. So we have now models.process mod filter, and then there is a resolver context. And then we have a mod filter. So, and then it says get mods new. So these are like, okay, these are filters. Okay, so this is how they add their fields. I mean, makes sense. And the only thing is that we have like this mod filter here. There is like mod process, rules process, mod filter. And we have to figure out what that does. Gets a default error, and then struct, and then apply changes. Okay, process mod filter. So that returns mod filter. And that has an add field thing. And then it says, okay, if it's any of these fields, we're gonna add it. Okay, so the question is now, what does it do with that filter object? So you then say get mods, and then it retrieves all the mods, convert it, make generated mod. So, okay, and so this is now like conversion between like a between a DB mod and a generated mod. Like generated mod is like for like generated mod is for GraphQL. And this here mods are like from the database mod, the data structure. So we have 2 times the same data structure essentially. Oh, yeah. So now create mod. No, get mods new. So here we say new mod query. We provide the context structure. We provide filter. We provide unapproved. We provide false, and then we try to find the mods. And then we have like db cache or whatever. So now, how does they construct the whole structure here? So they say they make a new query based. Okay, they use context for the database stuff. So they get a database out of the context. I have no clue how that works. So we're gonna have to look into context probably. So, okay, I get a context out of this, and then I say I query model mod. So for that we say, okay, it's all related about that mod. So then we have our where we check if we are unapproved or denied, and both is not allowed to be the case, or unapproved depends on the unapproved thing. So then we're gonna filter. So if the filter is unequal nil, so this guy up here, we're gonna go through here. So we don't have a search, so this is completely ignored. We do not have a count, so I'm not quite sure what this. So count is. So if it is false, it does some stuff. Whatever. What does count do? I don't quite. What does count do? Like, what do we set count to? So this here is where we can add. Okay, now. Mods. Mod filter, new context. I mean, we do not set count to anything, so I guess it stays at false. So we're gonna go filter, go through the filter and offset. I mean, okay, I'm fine with that. Like that's like paging essentially. And then we have filter, order by. And if that is unequal, mod field search, we then check, okay, it was ordered by the last valid version date. Then it does a weird query thing. But if that's not the case, we have order by, and order. Whatever. But it's probably mod field search, so whatever. Then we have filter equals nil, or then hidden equals false, where hidden equals false. So this has to be the case. If the IDs is unequal nil, this is not the case, or filter IDs is equal to 0, so this is not the case. We don't provide any IDs. And then we have filter references. Nope. And then we just simply query everything. So, like, this sounds to me like they do not do the nested stuff. So they say, okay, you can get all the IDs, but it doesn't care about the nested things. So I'm gonna have to check out how. I'm gonna have to check their GQL stuff. So go into schemes, and then there is mod. So there is a mod specified, and then there's get mods. And this retrieves mod and count. And then you have like authors. Huh. That sounds unhealthy. If this here retrieves all the mods, but it doesn't care about the authors. Where do the authors come from? Because like this here is get mods resolver. Here we again have get mods resolver, this time for count. But query resolver get mods, which then calls get mods. I mean, that's very obvious. But like deny mod, approve mod, delete mod, update mod, create mod. The question is, how does the nested stuff work? Latest version get my now. Like I say, give me the mods. And I want to get all the mods, and then there is a field. Oh wait. Right, so there is like there was a filter, if I'm right. There. So that means if you ask for authors, you won't get authors. Huh. So does it not be, so wait, does it not be, is it not able to do, fix it? I have to check before I'm stupid around. So I want to like get mods. Oh, this is so much nicer. This is dark, you know. Name, so ID, authors. ID. Failed to fetch. Please check your connection. Oh, wow. Oh, this is... Huh? Okay. Very weird. Cannot query field ID on type user mod. Wait. What is user mod? There is a mod. What is user mod? Update user mod. Update mod. Query. New mod. Mod filter. Mod fields. Huh? Like, get mods gives us mod. I'm confused. Validation failed. Cannot query field ID on type user mod. Heh. Oh, wait. Ah, this is the actual type. It's called user mod. Wait, what a weird thing to say. So you can get authors and there is user mod. And in user mod, what is user mod? User roles, then there is a user. And then you have mods and then user mod. And then user mod is user ID, mod ID, role, user mod. So you just query it directly, so it doesn't really. Wow. But like, wait, what? Why role? Oh, okay, then it's the role of what? But then you have like then you have your user, and then you have your mod. So wait, you say user. Okay. So you can say user, and then you say like ID. Like does that work, or what do you mean? Cannot query field user on type mod. Authors. More like that then. Like user ID. Is that what you want? How does that work? Where does this authors come from? Like, we just checked, so like if you go into here, add field, you do not allow authors. If it's anything else, it's not added. So this mods certainly cannot be the only thing, since like if we run that, you say get a wrapper. So you say get field context, resolve a context. Then you have like this thing here with unapproved stuff, and then say process mod filter, which doesn't get anything out of our needed stuff. And they got a mod filter, and you then continue onward, and then you have like here, and then for every field you try to collect, you are adding the field, and there you sieve out the stuff you do not want, like authors. So how and where do you get the authors from? Where do you get the authors from? It has to happen somewhere. But like, where? I mean, you have a mod resolver, okay. I understand. You have GQL types, which is okay. But like, you have to resolver mods, users, and then you have like rotation resolver, query resolver, user resolver, and there's like a user mod resolver. I mean, that's fine. The problem is just that I cannot find anywhere in here something where we are using a user mod, where we retrieve like, we have like mutation resolver, okay. Then we have a query resolver, which then uses like get mod to like then get to do the get mod thing, okay. And wait, now get mods. Where do we have get mods? Get mod by reference. And here we say generated.get mods. Get unapproved mods. Get my mods. Get unapproved. And then get mods resolver mods. Get mods. Generated get mods. And there is a get mods resolver mods. Okay, wait. We have here query resolver get mods, which then calls generated get mods. But what is this get mods resolver then? For what is that used? Like honestly, I don't quite get it. So like our resolver here goes, we have here resolver, but like then under schema.resolvers.go, we have now our query resolver, which then does the packages, and here we have our query resolver. Okay, so this here is actually where we have the query resolver. That's the one that matters, apparently. So maybe we are on track, because like this is the get mods resolver. I don't know where, why, or what, but it's there. But there is this generated get mods function. So there is one for the query resolver, which is this here. But what we actually care about is this guy. And this guy does weird shit. So it caches a weird key, whatever. Gets the database context, adds a limit and an offset to it. Proof denied. And then it does, if okay, that's like search query. And it tries to find all mods. Come on. Guys, I will be right back. Give me a second and yeah, see you in a moment. I'm back again. So get mods. In context, limit offset, that's the new query. Order where find mod set. And then done. But where do the authors come from? So like, there is if we go up, mod, authors, user mod. So, okay, maybe user mod. Maybe there is something like called user mod or something in the resolvers. So, like we have like get mods resolver, mods. Get mods.mods. Get mods.mods. And the question is like, when do we call like this here generated get mods? Wait, that's a structure? Okay. Oh, it is. So there is a structure get mods. Huh. So I guess get mods resolver mods then try is just simply the resolver for this mods field here. Okay, so this is get mods, and get mods is probably the output of a query. Yes. So we have like this get mods filter here. Where we have filter mod filter and then get mods. So we have like this mod filter, so we have, so it first calls the get mods, and that get mods has to return a get mods structure, and this get mods structure then has to resolve the mods and the count. Okay, let's have a look. So we have a query. So this guy here, query resolver, is now this get mods function, this get mods query function down here. So this query get mods is now getting called. This causes this here to be called. So that means the rep query trace is get mods. So what we're gonna do is we then gonna call generated get mods. So we create a new structure called a new get mods structure. So this is the model. So this here no, it's not. Thought it is. Wait, is it? No, it's not. Like get mods, query resolver, get mods and query resolver, cause generated get mods, curly brackets. So this would only work, and then we have like Postgres mod, Wait, this is a mod. This is not generated. And then we have resolver mods. So this here is not related at all because like you cannot, like you need a context here and stuff which we do not provide. So it really is just like this, like the interface. Get mods essentially. So like that's what it is. We just like create the get mod structure and then we just return that. So for that we return it. And then on this get mod structure, the resolvers for the get mods. So like get mods structure, resolver essentially. We then resolve the mods, like here you go, mods, and the count. Wait, we are doing two different queries? Get mod count new. Wait, we are actually doing two fucking queries? We are actually doing two queries. Oh my god. Huh. Huh. I mean, okay, this happens then. And then we have a mod, essentially. And if I have to guess right, there is now like, because like this get mods guy has now this mods thingy, and then we have a mod, and this mod has authors, and I highly suspect that there is a mod. There is a mod resolver for authors. So I think there is a mod resolver that then has a function authors. There is a mod. There it is. There it is. Oh my goodness. Okay, and then we are using here a data loader. Users mods by mod ID. Whatever data loader is and where it comes from, it exists. So it's inside here. ctx.value loader keys loaders. Oh my goodness. And then we say user mods by mod ID, and then we say load. And these are then the authors. Authors not found. Or we convert them. But that is like in the data loader. So we have user mods by mod ID, probably somewhere in here. So this here is okay, and this here is then these data loaders, which we have not finished read or read in detail. These guys here, because there's middleware thingy majig. I haven't had a look at that yet, so I guess that this stuff is this. Okay. new cache, whatever. It does. Why is there an echo context though? Why does it have to be why does it have to be weird? Why can't it be cool? Anyway, there is now user mods by mod ID. Oh, wait, it's a middleware wrapping around the GraphQL query, and then it puts stuff into the context. Got it. So context with value, so requests context, loader keys, loaders. And then we have the different loaders, and then there's user by ID. What did we need again? User mods by mod ID. And these are then the authors. User mods by mod ID. User mods by mod ID. Max batch 100. Wait. Time dot millisecond. Fetch. Weird structure. And we are creating we're creating a new query, essentially. So it heavily relies on caching, as it seems. It heavily relies on caching, which is odd. Honestly, in my opinion, that's odd, but who am I to judge? But it has to do many requests. So it does, first of all, it does a request for all the different mods. So then we get all the different mods. It then does a request for the count of mods. It's a separate request, and it gets the count of mods. And then it gets all the authors of a mod with this thing here. And then it has the list of author mods. And there it doesn't even care. There it just takes everything. It doesn't care about what we want, what fields we want. It just goes for it. At least that's how it seems right now, honestly. So... holy shit. It just goes for it. It just grabs it all. And then it stores, but it caches it. But anyway, it just grabs it all and then continues onward with the next stuff. Why? So it then grabs everything. And since we have like a query here where we then also want to get the user from each author, and then from the user the ID. So this is a direct link. So I guess since we then want the ID, so my guess is that after we got So like with the resolver, with the authors resolver, it grabbed all the authors and returned them. User mod. And now it goes into the user mod resolver. Let's check that guy out. It is very likely it now goes into the user mod resolver. For that we have to go into the users. If there is a users. It's just mod GraphQL. I need to go into resolve users, and then there is probably a user mod resolver. There, user mod resolver, where we have a user. Then it does again a new query. DB user to generate it. Where it then retrieves the user, and this guy then contains the ID. And it uses the data loader again. So that means it grabs everything. It doesn't care about the fields. It just grabs everything. And then it converts it back. I'm like, holy shit. Or does it care? Like, I can just see IDs. I cannot see anything related to fields. No, it just goes for it. There you go. There, find everything. Give me a new DB. Fetch the with all the IDs, and then just give me all. Holy shit! And then it stores it in the data load, and then it stores it in the cache essentially. I'm not quite sure how those data loaders work, so we're gonna have to investigate, obviously. But this here. Damn. So, like, let's count everything up. So that means if you do this query here, it does one query for the mods to get all the mods. Then it does one query for each mod if each mod has a different author. Wait, no, it has a different author, yeah, it has different authors lists, essentially. Okay, no, wait, those are probably gonna have been fetched, haven't they? No, they have not. No, they have not. So then we have a second query here. And then for each of those, we then have like batched inquiries, so that if there are multiple users of the same thing, that if we then retrieve to get the authors there, it doesn't happen. That's at least as how I understood it. So like we then try to get the, like we have mods and we try to get the authors, and each author is then like batch. And then we have like in each author stuff we then try to get, like the user ID. Like we try to get the authors, and here it just, oh no, okay, here it also uses the data loader for each mod. Yeah, okay, so there, and this here probably retrieves more retrieves than a user mod object. But if there are if the same user mod object is in there multiple times, it doesn't care. GraphQL looks like really inefficient to me. By the way, guys, we're gonna have to end the stream very soon. Okay. I mean, let's end the stream right now. Honestly, I'm shocked. I'm shocked at how inefficient GraphQL is. Kinda. But I mean, it doesn't make much difference if you do it with a REST API. But I thought you can like optimize it a little bit more. Like, okay, you have caching, but I mean, couldn't you make the queries better, the SQL queries? Like, it doesn't really do any joins. You nearly do no joins. Huh. And you have to reconnect all the time again. Or like change. Well, Terrace Puppet, bye, yeah. Thanks for tuning in. But it's quite late. Yeah, gonna end the stream now. I mean, it was still fun. We did we investigated still quite a bit. Like, we investigated on GraphQL, how to do stuff. I showed you my progress, especially in regards of frontend and a bit of backend. I will investigate now more into GraphQL. So the only thing we really have to investigate now are these loaders, these data loaders. Then good night, Pana. DrachYX, why are you now here? The whole stream I was alone. So yeah. Right, so we're gonna so the only thing that really has to be figured out now, it's, as it seems at least, are those data loaders for the optimization stuff. And yeah, we don't need file upload. So yeah, data loaders. And I think that's about it. So like, we know this resolvers, maybe scalars and schema directives, but like, we mostly now got it on how we can adapt our stuff, our API to GraphQL. The problem is it's just, I'm not quite sure if it's worth it. So that's why I'm gonna have to investigate data loaders and talk with Wilsold again a bit. And yeah, after that we're also gonna check if and after that I'm gonna have to do authentication and authorization. Sleeping since I have only one short day and only extremely long days, so I tend to fall asleep at evenings after a few long days. Okay, that's understandable. Damn. So yeah. Oh, and authentication in GraphQL we have to figure out, and directives. But directives are rather straightforward. I have already looked at those, so they should be easy. Actually, we read it, I think, but we haven't made it yet. But still, so like data loaders, and then deciding on if we're gonna make GQL actually, or if we ignore it and focus on REST API for now. I'm not quite sure. We will see. because we're gonna have to do the tag updating requests and stuff. So it means probably next thing I will do is after investigating GraphQL. I probably won't do GraphQL conversion yet. Doesn't worth it probably, because we can do most of the stuff in REST API anyway. So I guess I will go with authentication. I'm not sure if that will happen on screen or off screen, but authentication is interesting because it consists of talking with Google, of getting authentication tokens and stuff with so yeah, stuff like that. For now, I would say like the last question, as usual. Well, not as usual, because last 2 times we didn't, but now we do. And that is, who we gonna raid? And the answer to that is nobody. I'm gonna have to check who we might want to stream. By the way, Draimu, thank you very much for following. Welcome to the Coders Club, which was the day before yesterday. Okay, so I'm gonna have to check out Twitch. Satisfactory stream and Babel. So who do we have here? Some people. I'm still looking right now, but I don't know. Well, okay, then I guess no satisfactory streamer. So I guess we're gonna raid Lollipop G. Wait. You know. So, guys, then I would say thank you so much for watching. I hope you enjoyed. You enjoyed the stream. I enjoyed the stream. As said, we did still quite a bit, even though in the we are a bit shocked. So we will see how it will go. And yeah, then everything that is left to say is I'm Scott and I say bye bye until next time. And as always, keep coding.